All right, we're getting to the end of this season here. We've just got 5.7 and 5.8 left in this one. We're looking at now solving logarithmic and exponential equations. All right, and these are the ones that are going to be very often for the exponential without a common base. So let's go through here. Let's review. Simplify each expression. So bring it together. Log base 4 have to be the same base in order to combine them together. If we're adding them, that means we're multiplying it inside. So log base 4 of 100 times 2. So that gives us 200. And now you say, can I get that to a base of 4? No, 200 can't go to base 4, so it stops there. Log base 5 of 35, log base 5 7. We're subtracting, so we are dividing log base 5 of, if you're subtracting like logs, you divide, which gives you log base 5 of 5. Oh, now we can go further with this one. 5 to the what equals 5? We know that that's equal to 1. Now, I'm trying to figure out a little bit about this one yourself. Can you go through and use some algebra skills that you don't necessarily have learned, that you haven't learned yet, to be able to get to this answer? I highly recommend, again, pause, try to figure this one out yourself, and then come back in with me. Okay, let's start it off then. Log base 2 of x plus log base 2 of x equals 2. Well, I guess we look at this a couple ways that we could go about doing this one. First thing, I've got log base 2 of x and log base 2 of x. Those are the same. That really means I have 2 log base 2 of x equals 2. Because I got 2 of the exact same thing. Adding the same thing together, that's a double. Hey, let's divide the 2 over. So log base 2 of x equals 1. Now we've got a log equal to a number. Easiest way to go from here, let's change it to exponential form. Base stays as the base. 2 to the 1 equals x. Oh, that means x equals 2. We could have done it a different way. We could have at the beginning said, hey, I'm adding logs, so we multiply within. So that would give us log base 2 of x times x equals 2. That's log base 2 of x squared equals 2. And then from there, we can either take it to exponential form at this point if you would like, or easier, I would suggest, is bring the exponent down in front. 2 log base 2 of x equals 2. Divide the 2 over, log base 2 of x equals 1. And then we're at the same point that we were here. So there's always more than one way of solving the log equations. And you'll see as we go along. And then there's this verify the solution. Let's do that right now. That means let's make sure that 2 is the answer. So log base 2 of 2 plus log base 2 of 2 equals 2. Let's see. Log base 2 of 2. Oh, that's 1. Log base 2 of 2. That's also 1. So then we've got 2 equals 2. Hey, that checks out. We're now looking at a logarithmic equation. That's any equation that contains a logarithm and a variable. And we're going to have to use our laws all the way through. Let's get her started. Let's look at this first one. Log base 3 of 9x plus log base 3 of x equals 4. They have the same base. We want to get this into a log equal to a number. Let's do this. So let's combine these using our log laws into a single log. So combine into a single log. Let's do it. If we're adding, that means we multiply within the log. So log base 3 of 9x times x equals 4. Let's combine that. Log base 3 of 9x squared equals 4. Now I'm just going to stop there for a second. Take a little bit of an aside. This 2 cannot be dropped in front. You cannot take that 2 in front of the log. The reason being, the only time that you can do that is if you have log a b squared. That 2 has to be an exponent of the full base. Watch out for that. This 2 here is only on the x, not on the 9. Okay. So that's a common mistake that lots of people make. They try to bring an exponent down in front of a log when it's not to the full thing. There would have to be brackets around here, which there are not. There are not brackets, so we cannot bring that down. But we can, once we get it into a log equal to a number, we're going to take it to exponential form. So this was our log form. We're going to take to Expo form. That's our next step. Let's do that. The base stays as the base. So 3 to the 4 is equal to 9x squared. 3 to the 4. That's 3 squared. Squared. 3 squared is 9. 9 squared, 81. So 9x squared equals 81. Let's divide the 9 over. X squared equals 9. Now we're taking our square root of both sides. And if you take the square root, plus or minus 3. And then it says, verify the solution. That's not a suggestion. You must verify all log equations. Let's star that there. Let's put some nice stars in there. And we have to make a note. You must verify all log equations. Okay, gonna have to do this. Let's highlight that. You need to verify. Even if they don't ask you to, you still must verify. And you'll see that in the next question. So let's verify. We got positive and we've got negative 3. Let's try positive 3. So that means log base 3 of 9 times 3 plus log base 3 of 3. Does that equal 4? Let's find out. That's log base 3 of 27 plus, hey, log base 3 of 3, that's 1. Now 3 to the what gives us 27? Oh, that's 3. 3 to the 3 equals 27. Or, in other words, log base 3 of 3 cubed is 1. Bring that exponent in front, which gives us 3 log base 3 of 3 plus 1. Log base 3 of 3 is 1, so that's 3 times 1 plus 1. That's 3 plus 1. That's 4. That's good. So x equals 3 is a solution. Let's check out negative 3. I'll change colors here, and let's plug her in. Log base 3 of 9 times negative 3 plus log base 3 log base 3 of negative 3. Let's see if that equals negative 4, or sorry, equals 4. Let's find out. All right, we've got log base 3 of negative 27. Whoa, wait a minute. Right now, that's a no-go. This is a no-go. You can't take the log of a negative number. Can't take the log of a negative number. And that's because of our domain. Our domain has to be greater than 0. The asymptote stuff. That's why we did all the work with our graphs first. You can't take the log of a negative number. X equals negative 3 is a no-go. So our only answer is x equals 3. So answer, x equals positive 3 only, not the negative 3. The negative 3 is extraneous. It's an extraneous answer. Now you could also be verifying with your graphing calculator. Graph left side, graph right side, or graph the two equations and find your intersection. Or equate it to 0 and find your 0. The number of intersections you have is the number of answers you have. If there's only one intersection, there's only one answer. So when we look at this one, when we graph y equals 5, and the other side, we can now find our intersection points. So we've got our intersection right there, which is 4 and 5. Obviously the y is going to be 5 because that's what we graphed the left side. So 4, that's the only answer, not the negative 4 from their example 1. Use the intersection feature on the calculator there. Got her. And you can see all the way through, again, talking about the extraneous roots. In example number 1, the goal was to get a log equal to a number. This is the second type. This is where our goal is going to be to get a log equal to a log. One on each side only. Okay, so for part A. For part B, we're going to get log equal to a number. But let's look at part A. Let's work it through. Okay, well, I've got one log on the left side, so we're just going to keep it as log 6x. And these are all base 10. If they don't show the base, we know it's base 10. Equals log. I'm adding together, so I'm going to multiply inside. X plus 6 times x minus 1. Inside one log. Do not multiply two logs together. Two logs added gives us one log with a multiplying inside. Let's expand that inside there. So log 6x equals, boom, 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 boom. Let's expand that baby up. So log of gives us x squared minus x plus 6, so x squared plus 5x minus 6. Now I've got one log equal to one log. If I multiply both sides by 2, it's still equal. If I divide each side by 5, it's still equal. If I square both sides, still equal. And we've seen before, if I log both sides, it's still equal. If I delog both sides, or drop a log on both sides, it's still equal. I can only do this when I get one log equal to a log, then we can drop a log. I know what you're thinking. Let's just keep it to math here. 6x equals x squared plus 5x minus 6. Whenever you get a quadratic in this course, and you're going to get it lots of places, if you get a quadratic, equate to 0 and factor. So let's do that. 0 equals x squared minus x minus 6. And then we factor that up. So 0 equals x minus 3, x plus 2. So that means x is equal to 3 or x is equal to negative 2. But we got to verify. Even if they don't ask you to, you must verify. Plug it in to make sure you do not get an extraneous answer. you got to make sure that when you plug it in, the original, everything is still positive. So let's start with plugging into all the x's. Let's start with the 3. So we take the 3, we plug it in, we get 6 times 3, that's 18. Log of 18, not a problem. That's a good number. 3 plus 6, that's 9. Log of 9, no problem. I can handle that. 3 minus 1. 3 minus 1 is a positive number 2. I can do log of 2. This one's going to work. That one's good to go. That one's an answer. But we've got to check negative 2. You plug negative 2 in for the x, and all of a sudden we've got log of negative 12. So log of 6 times negative 2 gives us log of negative 12. We can't take the log of a negative number. As soon as that happens, that's a no-go. This one is a yes-go. That one is fine. So we can see that the negative solution was extraneous. You can't take the log of a negative number. Let's look at the next one here. I've got 3. I've got a number on one side, so I'm going to try to get log equal to a number, or number equal to a log. Doesn't matter. When it was a log equal to a log, what we tried to do was get it to a log equal to log, and then we dropped the logs. You drop a log on each side, you're good to go on that. If we can get a log equal to a number, the way we're going to solve this one is take to Expo form. You remember those 2 keys, you'll be able to do any of these log equations. They always come down to these 2 methods. So here we go. Got a number, so good. On the other side, let's combine it into a single log. We're adding, so we're going to multiply. So it's going to be log base 2 of x times x plus 2. Let's distribute that in. 3 equals log base 2 of x squared plus 2x. Take it to exponential form. We now have one log equal to a number. So then x squared plus 2x equals 2 to the 3. 2 to the 3, that's 8. We've got x squared plus 2x equals 8. Hey, we've got a quadratic. Whenever you get a quadratic in this course, you equate to 0 and factor. So x squared plus 2x minus 8 equals 0, and we get factored x plus 4 and x minus 2 equals 0. 2 answers, x is equal to negative 4 or x is equal to 2. We got to test them both out. Take them, plug them back in for the x, and check to see, do we get any logs of a negative number? So let's start with the negative 4. That's usually the risky one, so we'll start there. Taking the negative 4, plugging it in, negative 4 plus 2 is negative 2. Can't take the log of a negative number, boom, right off the bat. Or if we plug it in for there, log base 2 of negative 4, nope, ain't gonna go, done deal. That one's out of luck. So this is a no-go on that one, extraneous. Let's check out the 2. Log base 2, 2 plus 4, 2 plus 2, that's 4, log base 2 of 4, that's good. Take our, so I went and put it in there, that made it log of 4, no problem. Log of 2, no problem. This one's going to be good to go. So that will be our solution. X equals 2 is the solution. You can also verify by plugging it into your calculator, left side, right side, looking for the intersection points. Your calculator will only give you the ones that work. Your calculator cannot get your extraneous. If you're asked for an extraneous solution, let's say on your diploma exam, they ask you, here, part 2B, same question, the extraneous solution is, the only way to find it is through the algebra. You have to do it algebraically. So can only find extraneous solution by doing algebra. You cannot solve it graphically and get that answer. That's why I think they might try to throw something like that at you. So now in 5.3 we talked about solving exponential equations, but they all have the same base. Now we're going to do them without the same base, and we're going to have to use logs. There's always two ways that you can solve these. So first way to solve this is probably the more common way that people use. And that's, hey, I can multiply both sides of this equation by 2, and it's equal. I can divide 5 to each side, it's equal. I can add 6 to each, and it's the same. I can log both sides of an equation, and it is still equal. We're going to use base 10 logs, because that's what we can punch into our calculator. So I'm going to log both sides of my equation. I just slap the log in front of there. So you slap the log in there, and then I can now bring down, we'll keep it with math here, x log 4. So bring that x down. Let's divide the log 4 over. So x equals log of 12 over log of 4. That's the exact form. If you're asked for exact form, you'll leave it like that. If you're asked to go to the nearest hundredth, that's when we plug it into our calculator. Don't forget that you got to have the brackets ended on the 12 when you plug it to your calculator, and that comes to approximately 1.79. But we could have done this a different way as well. I didn't need to slap that log in on both sides there. What you could do is you could take it into logarithm form. So straight from here, 12 equals 4 to the x. Let's take it to log form. Log base 4 of 12 equals x. Slide down over. And now we're going to use our change of base rule that you learned in 5.6 there. X equals the log of 12 over the log of 4. Punch that into your calculator. Oh, look at that. It's exactly the same as this one up here. All right. So the next one here. Notice that we've got this 3 kicking it in front. We just want to have a power on one side. A lot easier if we can divide that over. So let's do that. Let's start by dividing the 3 over. That gives us 12 equal to 2 to the x plus 1. And now you've got the two methods. Either log both sides or take it to log form. I'm just going to log both sides. That's what most people tend to do. So I'm going to log 12 equals log of 2 to the x plus 1. If you want, you can bring that x plus 1 down right off the bat, because you know that it's going to be an exponent you're going to bring down. And I don't mind you doing that in one step. If you want to do it in 2 steps like I did here, write it here and then write it there, go with it as well. The next thing, log of 2. That's log base 10 of 2. It has a base on it. Log base 10 of 2 is just a number. That number can be distributed in. It's a coefficient in front of x plus 1. So let's just multiply that in. We'll distribute that in there. And we get log of 12 equal to x log 2 plus 1 log 2 as we distribute it. So the goal here is the same as you do anything else with any variables. Treat it the same way that you would something like 12 equals 3x plus 4. you would just subtract the 4 over and then divide by 3. Do the same thing. Exactly the same thing. So we're going to subtract over the log of 2. Oops. That's not what I wanted to write with. Let's subtract, there we go, the log 2. We'll subtract over the log 2. We can't just go 12 minus 2. No. It's log of 12 minus log 2. So we're left with, at this point, x log 2 on one side is equal to log 12 minus log 2. I just switched my sides, not a big deal. And now we're going to divide by log 2. So then we've got now x is equal to log 12 minus log 2 divided by log 2. Those log 2's cannot cancel off. You got adding and subtracting holding you back. That's the exact form. That's as simple as you can make it. In that way, you could bring the numerator together if you wanted and go to, not that you have to, but you could go with log of 12 divided by 2 over log 2. So x equals log 6 over log 2. You could do that. You don't need to, though. There's also other forms that you could have gotten that look different but are the same value. That's one of many exact forms. If we punch it into our calculator, 2.58. These are exponential equations. They're not log equations. Log equations you have to verify. Exponential equations, you don't. So when we get the answer in these, that's the answer. The log equations, we do have to. The reason being is that there is restrictions on the log equations that we have to take into account. All right, last question here with these. Let's start this. This is the type of question I really think you have to be able to do. So, graphically going through, being able to get the answer, graph left side, graph right side, find the intersection point, great. Make sure you can do that. But also the algebra now. In these ones, we don't want to use the take it to exponential form, or to log form. We want to log both sides on any of these, because it's got a variable in each side. So we're going to log both sides. So log of 3 to the x plus 1 equals log of 6 to the x. You could have brought those exponents down right off the bat. Make sure that you've got brackets around that exponent. So far, the same as what we've done, except we've got x's on both sides. Log base 10 of 3 is a number. I can distribute that in. So let's do that. So we've got x log 3 plus 1 log 3 equals x log 6. And let's take it here. I'm going to go on the side now for a bit, and we're going to look at this without logs just to see how you would solve it. Okay, so I'm going to just get rid of the logs. Let's just use some algebra. This is just an aside question. Let's use some different numbers. Log of 3 is just like any other number. Let's just say 5x. Plus, log of 3 is just some number. Let's just use a number. Doesn't really matter. Let's say 8. Equals. And, oh, that one I missed the x on. Let's put the x back in there. Let's say this one is 3x. We're going to treat this exactly the same. The algebra that you would use for 5x plus 8 equals 3x is identical algebra you would use if there's logs in it. It just looks scarier. So in this case, I would bring all of my x's to one side and all of my numbers to the other side. So I would, at this point, bring over the 3x this way and take the 8 that way. So then I would get 5x minus 3x equals negative 8. And then I would combine these together. I'd say 5x, take away 3x, that's 5, take 3 x's equals negative 8. So 5 minus 3, And then I divide that over. We know that that's 2, but I'm not going to actually write it down. 5 minus 3 is 2, so then I would say divide each side by 5 minus 3. So then x is equal to negative 8 over 5 minus 3. But you could get to an answer, but I don't really care about that. That's not what we're learning here. Let's come back in here. Do the exact same thing. Let's get our x's to one side, our numbers to the other side. Log 3 is just a number. So we've got x log 3 minus x log 6 equals log 3. And then just like we did with the other numbers, what I did here was I combined my 5 minus 3. What I actually did is I factored out an x. They both had an x. I factored out the x. So factor out an x. Let's use that same strategy here now. So factor out an x. Write that down. Factor out an x. That's the key. That's the part where lots of people get messed up on. Factor out the x. X bracket log of 3 minus log of 6 equals log of 3. And now we divide it over. So x is equal to log of 3 over log of 3 minus log of 6. There's your exact value. If we need to punch it into our calculator, we would do so and come up with 1.58. Again, we could combine the 3 and the 6 together. Oh, I just noticed something here. Please make note of this. When I brought over the 3 log, that should have been a minus sign there. That should have been minus. That should be a minus sign. Please make note of that. Negative there, negative there, negative there. Good thing I caught it. Okay. 1.58 is right because I looked at the answer key. Okay. Finish up those, discuss the ideas. Hey, what do you think about those? And we're done.